Okay, I'm assuming the share is working. Okay, so this website, it's kind of like GitHub, but for Grasshopper. So there's a lot of plugins and things here that you can use for Grasshopper. As I've explained before, I mean, Grasshopper is great as it is, but one of the big advantages of it is how many people have made plugins for it over the years. And there's a lot of different stuff you can do with it now. The plugins we're looking at today are quite generic. Like they'll do a lot of important stuff, but they're not that specialized in certain things. There's a lot of plugins that are specialized for specific industries. A lot of it's in architecture. So there's stuff for BIM modeling or like sun analysis or things like that. There's a lot of stuff for shipbuilding. So if you're into shipbuilding, there's plugins for that. But there's plugins for really anything. There's plugins for robotics, plugins for art, plugins for Illustrator, for Grasshopper. Like the list is pretty extensive. If you see on the main website here, there's just over 1,000 plugins on this website alone. This is the host of most of them, but there's some plugins that are on like personal websites or things like that that people have coded. But if you're ever interested in what plugins exist, there's a bunch here all organized, so you could take a look at that. Today we're looking at some of the most important ones. So I sent links for Dendro and Pufferfish as well. But the first one that we'll look at is the shortest walk plugin. What this one does is we played with Voronoi diagrams last week. This one can take any diagram made up of lines and with 2 points just find the shortest connection between the two with a line. It might not sound that interesting, but we'll make some cool wearable art piece today with it. So there's a lot you can do. If you scroll down on any of the pages, there's going to be this section, this kind of grid of downloads. This is like everything that's ever been posted, but we'll always want to download the most up-to-date one on any of these tables. So this one doesn't have too many. Pufferfish might have a lot more, but we'll get to that in a second. So if you download this top one, this one from 2012, this is the most up-to-date one. That should work for today's class. So you can just hit download, and it should give you a zip file onto your downloads folder. Do not unzip that file just yet. Okay, actually this one did not give a zip file. Sometimes they do. It doesn't really matter though, as long as it gives a file. So let's take a look at it. So it should have downloaded. It should say shortestwalk.gha. That's a Grasshopper assembly file. We'll install this into Grasshopper and Rhino in a second, but before we do that, the most important thing, you need to do this for every time you download something from Food for Rhino, is to right-click on it. Go to the Properties tab in Windows 11. It looks like this. Windows 10, I think it's at the very bottom. On a Mac, if anyone has a Mac. I have no idea. Does anyone have a Mac in here? Yeah. Are you running like Parallels or a Windows partition? Or are you just on Mac? Okay, that might be an issue later on because most plugins are written just for Windows. So usually in the past, people have done like a partition for a Windows desktop on a Mac, but we can cross that bridge when we get there. So yeah, if you go into Properties, there should be a button called Unblock, and this will just let your computer run it, and it won't read it as like, I don't know, someone trying to harm the computer. You have to do this for every plugin. I don't know why they set it up like this, but it's just how it goes. So if you hit Unblock and then hit Apply, that checkbox should go away, and you can just hit OK to close that. Is that working for everyone, or is anyone having issues finding that button? Interesting. If you right-click, go to Properties, and then it should be on that main page. I mean, you have Windows 11, so it should be there. Yeah.
Yeah, I can't find it either.
What Windows are you running?
I think Windows 12.
Windows 12.
Wait. Whatever is most recent.
Okay, well, it might be most recent. I'm not sure. I never update anything, which might become an issue later on in this course, but we'll see. I mean, maybe it's fine. I'm not too sure. Usually there is an unblock button, and you just hit that. So, but we will see if it works or not in a second. Yeah, we will see in a second if it works. If not, we can try to do some more things. But okay, so once you've done that, we can open up Grasshopper. We can install it straight through the Grasshopper window, so make sure you have this open. Okay, with this, there's no just install button for most plugins. So what we have to do is, with the Grasshopper window, if we go to File, at the bottom, we'll see this one called Special Folders. There's two special folders that we care about here. The first one being the Components folder, and the other one being the User Objects folder. Both of these are for plugin files, and they're for specific kinds of files that you would download. So we'll get to that in a second. Right now, if we just open the Components folder, that should open up an Explorer window on your desktop. And yours is probably blank. It probably has nothing in it. Mine has some other plugins from before. But we can pull up both windows next to each other, or you can copy and paste files back and forth however you see fit. But we'll just want to drag the shortestwalk.gha file into this new window that's opened up for Grasshopper. Once you drag it in, it should just sit there and say shortest walk, and then you're good to go. If you want to organize things, you can put things into folders. If you want, it's not going to mess with the file structure, but all you really have to do is just drag it and drop it straight in, and you should be good. So with that, you can close this window. Don't need that anymore. And then you'll just have to restart Rhino for the change to take effect. So close Grasshopper, close Rhino, and then just reboot both. And then once it comes back up, I'll give you all a few seconds, and we can see if it installed correctly or not. So. Wait, what file type? Did you double click on it? Oh yeah, don't do that. All we'll have to do is drag it into the components folder and then close it out, but we're not actually like opening the file. So there should be no reason to double click on that download. Yeah. It does, yes. Did it not just transfer it over correctly, or okay? Yeah. For everyone else, if you do have Grasshopper open again, if you add a new component, just like we did last class, if you double click on the canvas and type in shortest walk, you should see this kind of icon showing up. If you don't, something is wrong, but this is what you should see. Okay, so who's able to see this component in Grasshopper? Yeah, it's good. On Zoom, you all see it?
Yes.
Cool.
I have a Mac, so I can't download it.
I see. Yeah,
So I'll just
that would be an issue. Yeah. No, it's working on Mac. And you're not like running Windows off the Mac? Okay. Joe, you mean you can't download it at all, or just it doesn't run?
Well, honestly, I didn't try to download it only because it doesn't have the Apple symbol next to the program.
Okay, yeah, we have one student in here saying she was able to run it.
Interesting. Okay, I'll try it.
Yeah. Yeah, sometimes they're weird. I mean, most of these developers, they just do it for fun. So usually they just code for Windows. But anyone in here still not able to see it? No? Okay, I'll walk around. I'm gonna put this mic down for a second. You should, if it's already in the library, yeah, you should just be able to restart. So I just want to see it. I don't know if it's okay. Yeah, I think that's good. If not, then just like yeah. Okay, so you open up the yes, the break. Yeah, so if you double click on the campus, so not on an AC button, double click it. Yeah, and then just type in shorts. Yeah, there you go. Looks like the bottom. There you go. Awesome. Yeah. Okay, anyone else? All good? Okay.
It worked.
It worked? Good.
Yeah. Yeah.
Cool. Perfect. So let me see. Okay, so that's one way to install a plugin. That's kind of the easiest way. It only had one file. Now that you know that, I put two other links in Discord. The same process applies for these, so Dendro and Pufferfish. So let's look at Dendro first. So again, just do the latest one. This one is from last year, so 2022. And this will download as a zip file. The process is the same for this one, although you can just unblock the zip file before unzipping it, and that'll unblock all the files inside. So I would definitely do that. It'd be a pain to unblock every single file that's in here. And does everyone know like how unzipping a zip file works on their computer? Cool. Okay, so inside Dendro, we just have to find the place. This one comes with a couple different folders. But we don't need the documentation or the examples. We just need the actual plugin. So plugin files come in a few different types. We just saw .gha for shortest walk. Dendro also has that, but it also has some .dll files, just a different file type. But all of these, again, go into the components folder. So if you understand the process from shortest walk, hopefully this is just the same. Just put both of these in the components folder. You could even just put the libraries folder straight over instead of doing both of these separately. Up to you though. So I'll give, which one? You need both of them, yeah. Yeah. Yeah, so I'll give you a few minutes to do that. If you have any questions, let me know. We'll do pufferfish just after this one. Yes, you can take the libraries folder from Dendro and just bring that over. Documentations for you to read, examples are actual Grasshopper files that we can open if you want an example of how things work, but for the plugin, yeah, just the libraries. Pufferfish has a slightly different method, which we'll go over in a second. Yes, in the components folder, yep. Yeah, that's a good question. So what components would you see if you installed Dendro? Shortest walk is unique that it doesn't put a bar up top. Dendro, you'll get a new tab at the top of the panel that should just say Dendro. Yeah. No, you don't have to do anything with the examples, just the libraries folder. Okay, so the last one is pufferfish. So if you have that link pulled up, again, just download the most up-to-date one. So V3 from 2021 is the most updated. Again, just unblock that zip file. And I already have it, so. Okay, how's over there, Dan? Do you have pufferfish downloaded? Okay, cool. Anyone having issues getting Dendro? For the Dendro download or for? Yes, there should be shortest walk and then the 2 Dendro files. Yep, perfect. Do you have pufferfish downloaded? Yeah.
This came in, so this is shortest walk,
Yep.
which came in as an assembly. This came in as assembly, but this is from Dendro, just
Yeah.
the libraries.
Yeah, perfect.
Should it say that it's Dendro or?
No, it doesn't matter. It really doesn't. Yeah, that's perfect. Require it to say much. So yeah, that's good. Okay, so for pufferfish, you'll notice there's a new thing here. and it's not the text document, it's actually the sub-D components folder. Just like last time though, pufferfish 3-0.gha will go into the components folder. That's standard. But if you open up the sub-D components, you'll see all these files end in .gh user. And if you can see the color of them, they're orange. It's another tell. But these are slightly different to install than the .gha. Usually what I go by is if the file is like green or white, then it goes into the components folder. But if it's this orange one, this is the only one that goes into the user objects file window, which you can see it has like a user at the end. So let's see here. So special folders, the other one I talked about, the user object folder. So .gh user, they go into the user object folder. And we can see I've got my pufferfish sub-D components folder sitting in here. So again, file special folder user object. And you can just take that whole folder from pufferfish with the user object files and put them into this folder. Yeah, the plugins will never work unless you restart.
That one is technically called the WIP, so
Yes. Yep.
If we're using Rhino 6, is there any use in installing the sub-D components?
You make a good point.
Just go ahead and do it if I ever upgrade.
Yeah, I mean, just do it, see what happens. I mean, I don't think we'll make much use of them, but I mean, it is good to have all the plugin installed if you're going to install a plugin. I mean, it says it'll work for Rhino 6. Let me see. And with pufferfish as well, you'll also get another tab that pops up. And the sub-D components, yeah, I don't think we'll ever make use of them, but yeah, just do it anyway.
Okay.
Yep. Okay, anyone having issues with the last install here or on Zoom? Let me know. Okay, if that's working for everyone, in Discord under the file sharing channel, I just posted a Grasshopper file. If you go ahead and download that, we'll start with that file. It just contains like a base mesh of a person. that we'll use for the remainder of the course to start modeling things on top of. So just open that up. You should see like a green outline of a person come into the scene. Should be perfect. Is everyone able to get that up? Yeah? Yeah. Oh, like as a separate file? Up to you. Yeah.
Or do we access it each time from Discord?
You could do that as well. One thing I will mention though with like Grasshopper files is Rhino. Do you know, have you worked in Rhino before much? Okay, so Rhino files and Grasshopper files are separate. So if you save Rhino but you don't save Grasshopper and you close it, like all your Grasshopper work will be lost. So, I mean, it's not exactly your question, but I would just save everything as much as possible.
So we'll just open the Rhino base first file.
Yes.
We'll
Mhm.
go back to that, like save it as something we'll go back to and start from.
If we ever do in this class, I'll give you like the file to start with. So, yeah. Okay, so everyone has this open. Cool. Good. Awesome. Today in class, we'll be using shortest walk to create some kind of generative type of adornment for the body, you know, dynamic wearables. So we'll be creating something like this today. We'll use all 3 plugins to get to something like this. So should be fun, and we'll all get something unique based on the random number sliders that we all choose. And we'll put some images in Discord after the class, so that'll be fun. Any questions before we start? Does everyone kind of understand what the shortest walk algorithm is doing? I'll show just in case. Okay, so this is like a Voronoi diagram that we have from last class. So we have that. What I've done here is I've given it a line, basically saying, can you draw me a path based on the diagram that connects these 2 points? And what the algorithm has done is, if you can see in green here, it's made this line following the Voronoi diagram to connect those 2 points. That's basically all it's doing. It's just finding the shortest distance between 2 points following some kind of input curve grid that we gave it. It doesn't have to be 2D. It can be any shape, as long as you have, what is it going to call it? A curve group and a path that you want to find, it'll find that path. So that's the simplest definition. You could do something as simple as this to get it if you're doing like city planning or finding like a road network or something, Google Map style, you could do that. But we'll try to be a little bit more creative today and make a wearable that goes on this person. So we'll utilize a lot of things today, the plugins that I talked about, but also some curve handling techniques in Grasshopper in 3D, which is more complex in 2D, but also a lot more helpful when you're doing 3D modeling. And hopefully we'll learn something. So we'll kick it off with this person. Shortest walk, as I said, it needs that curve diagram to make a pattern on. So the first thing we'll have to do is generate that diagram on this 3D figure. We did something similar to this last week with the 3D Voronoi, where we're doing cells in 3D. This time though, we'll be doing it on a mesh. So a little bit different, but the same kind of workflow applies for getting that step. If we need a diagram, most always we'll start with a group of points. Would anyone know from last class what you would do if you want to put points on this mesh to start with? Yeah?
On the mesh.
On the mesh. Close. It would put points in the scene, but it would do them kind of in a large rectangle around the person, inside and outside. So we can see here. Which it could give us some interesting things, but it'll be best if the points are actually on the body, so on the mesh itself, so we can draw that diagram over all the forms. Yeah, geometry will do perfect for this use. And we'll get points just on the surface of this mesh. We can do as many points as you want, again, if you want to add a slider. By default, it's coming in with 100 points, but we could up that if you want to however high. Assuming, again, everyone remembers how to add a slider into the scene. We can add as many points as we want. Just know that the more points you add, the more time the algorithm is going to take. The more operations we do to it, the more it's going to have to think. So it might not take long now, but in the future it could be a lot. So I'm just going to keep it low for the moment at 100. Okay, so we'll have to create a pattern on the surface of the mesh. If there was a component that could do a Voronoi on a mesh, that would be perfect. But if you remember from last class, the two choices we have, and you don't have to do this, but are the Voronoi that does the Voronoi 2D, and then we have the Voronoi 3D. If you remember how these look, the 2D though is just making a pattern on a plane, which isn't going to work well for wrapping this around a 3D form. And the Voronoi 3D is going to give us really big cells that don't really wrap onto a mesh. They kind of just envelop the points that they sit on. So there's no great option to put curves on the mesh, but there's ways we can use these components to figure out how to put the curves on the mesh with a few more steps. So Voronoi 2D is not going to help us too much. Voronoi 3D at least gets us to a 3D point where we have 3D cells. So we'll start with that. Just like last class, we can use the points in the P input to actually tell the cells where to populate. So if we do that, just like when we used the populate 3D a second ago, it's going to make a rectangle boundary around the figure that we have here. So we have a Voronoi cell in 3D, so we're getting close, but we actually need to find the curves on the mesh itself. So hopefully this step is easy enough. We did this kind of last week. Looks pretty good on most people. So in order to find the curves on the mesh, does anyone have any ideas of how you could find the curves on the mesh from this point in the workflow? Yeah?
You have to like find like the intersection, right?
Yeah, the intersection would work quite well. We have the cells, and if we zoom in, the cells intersect with the mesh. We can kind of see an outline right there. So if we found the intersection, then that would give us a group of curves actually on the mesh. So that'd be perfect. We can easily do that. There's a lot of different ways to find intersections in the intersection tab. Most times, though, will usually be under this physical section. So this can find intersections from a bunch of different types of geometry inputs. I kind of talked about it last class, but there's a lot of different types of geometry in Rhino. You've got points, curves, B-reps, meshes, sub-Ds, a lot of different things. And they all act a little bit differently, so you'll want to use components that match up to the geometry that you have currently in your scene. Right now, actually, does anyone know what the Voronoi cells are, technically? Yeah, it does say it if you hover over, so it's giving us closed B-reps, which is good to know. So we have B-reps, and then the mesh itself from the character that we brought in. This one, it's telling us it's a mesh. So we have a mesh and a B-rep. Those don't really combine too well. It'd be great if there was two B-reps or two meshes, and then the data would line up. So a little fact about Grasshopper is usually it's a lot easier to convert from a B-rep to a mesh than it is to convert from a mesh to a B-rep. That's a lot harder. B-rep is a boundary representation, so it's like a mathematical way to define a volume. A mesh is just polygons, so a bunch of triangles. So the easiest way being going from a mesh, or from a B-rep to a mesh, we can do that quite easily with a component called mesh B-rep. This will take any B-rep and just add the triangles to it to make it a mesh. So that's just one step. And then we can take those Voronoi cells, plug them into mesh B-rep, and now coming out, we should have a bunch of meshes, which is perfect. So at this point, now that we have two meshes, it's a lot easier to find the intersection between two meshes to give us curves. So we see we have a lot of options here. We'll just want to pick the one that best fits with the like the situation we find ourselves in. So if we have two meshes, there's this one called mesh intersection, which will work perfectly for us. You can find it here. You can type in mesh intersection, but that's kind of long, or you could type in MMX as an abbreviation. That'll also give you the component. So a couple different ways to find that. Okay, we have two meshes. We have two inputs, A and B. Probably obvious what the two inputs do is for the two meshes. So we'll take one. Doesn't matter if which goes into A, which goes into B. We can plug those both in, and then we will get the curve groups that actually intersect on the mesh itself. So hopefully that's working. At this point, we can hide everything before the intersection just because it's going to clutter up our scene a little bit. So if you remember how to do that, you can either right-click on a component and preview it off, or you can mass select everything, right-click off on the canvas and just preview off there. Or if you hold the middle mouse button, we can also use the hot menu just to turn it off as well. Cool. So hopefully everyone's getting curves on the mesh. Similar to this, probably a little bit different than mine, but similar. I see confused faces back there.
No, I just can't get rid of my box.
Okay. Cool. So if we have the curves, we can introduce the shortest walk at this point. And we'll just see what we need to build up to this step. So as always, you can hover over any of the inputs or the outputs on any component, and it'll tell you the name of it and a little bit about what it needs to be accepted as an input. So if we look over the three of these, C is the input curve group. L is lengths for each curve. This one is also optional. I don't know if it says optional. There are no lengths, then the length of the curve is going to be computed. So we don't have to fulfill this. And then we'll look at P. So this is the wanted path, so the direction that we want the curve to flow in. So if we think about these, we have this first one, so the curve group. We just created that. So we have all those curves. We have the curves, but there's a couple things that we want to do for cleanliness sake, just to make sure there's no weird issues with the curve group. Right now, since we're generating curves on kind of this random mesh, they are curves, but just in the workflow, we don't know how clean they are. There could be curves that are very, very tiny that don't work well, and there could be sections where the curve just ceased to exist during the intersection, which might be issues you would run into later on. But for cleanliness sake, we'll go over that just so you're aware. So with the curves right now, let's actually, you don't have to do this part. But if we take a look at just pulling out one of the curves from the list, where would that curve be? Okay. So we can see there's a curve here that's kind of wrapping around the back of the arm. Right now, this curve is separate from every other curve, so it's kind of forming its own little boundary, which makes sense if we think about the Voronoi cells, because they were all separate parts. And if we want this line to be able to walk through the entire grid of lines, per se, then we'll want to put them all together. So right now, it's not great if they're separate. What it would be best to do is actually break up all these curves into their tiniest segments, so we can have those all as one big set of segments. The easiest way to do that, it's in the curve tab as well. There's a lot of things you can do to affect curves. I think last week we broke a curve up into a lot of points for that 3D Voronoi diagram. In this sense, we can grab the explode component, which will take a lot of curves and it'll break them up into their smallest segments. So right now, we have a bunch of polylines coming out of the mesh intersection. And those polylines, if we zoom in real close, we can see they're made up of smaller segments. And the explode will just take those curves and break them up into those small segments. So if we run the intersection over to the curve input, you'll see it'll start to explode these curves, and we'll get a lot of vertices on the curves as well in those places where it broke the line up. Who can tell me what the dotted line means again in Grasshopper, if you remember from last week? Yeah?
I'm not sure.
Yeah, go for it.
Is that like the multiple like values or root inputs?
Yeah, it'd be multiple branches of data. So they're all broken up like into their own separate folders. So right now we're not seeing them all together. Again, if we want the curve to be able to walk through everything, then they'll all have to be together so it knows it can walk through everything. So that's easy enough to fix. We can right click on the output of the mesh intersection and just flatten that. And that'll take all the branches and just flatten them into one single branch. So now all the curves are on one branch, and now they're all also exploded into individual line segments. So we can see that on the S output is the segments. And we've got all the segments here. You'll see again though, and you'll get used to this as you use Grasshopper more, but hovering over the S output, we can see, again, these are now on branches because we did explode the curves coming in, but now that it's broken up every curve into smaller segments, it's placed all those segments on a branch that relates to its original curve. So if there were 5 curves, now there's 5 branches of segments that relate to those curves. It's broken this up just to keep the data consistent. If it were to just put all these curves together in the same branch, that would kind of be destroying a lot of our data hierarchy as we move through Grasshopper. So since it's grafted them again into separate branches, we can flatten this as well a second time. So we flattened it twice. And now we just have around 10,000 curves coming out, all on a single list.
RJ, do we always want to flatten a dotted line, or is there sometimes you'd want a dotted line?
No, there are times you would want a dotted line. Yeah, so let's trying to think of how to explain this. So okay, I'll explain this quick, but you don't have to follow along with this. Say we had a bunch of cells on here, like points, and we drew a circle on every single point. Now, if we broke the curve up into each circle up into, I think, 10 different points, so we have all these points. If we were to, we'll have this one as the flattened, and this one as the non-flattened. So we have that dotted line again, because there's 100 circles, and then each of those circles was broken up into 10 points, and each of those 10 points was put on a separate branch corresponding to every circle that came in. So this one up here is flattened, so all the points are on a single list. This one, they're still grafted in separate branches, so they're all together like that. We'll just hide all this. If we were to take the average of all these points, you can see if we start here, we have these points. If we take the average of every single point, we'll get the point that's right in the middle of everything, so that's the average. If we were to apply this to these two, we can do the one where everything's flattened, and we'll see that point goes back to the center. If we do it on the ungrafted one, we'll see the average of all these points will go to the center of each circle, which again is this, the same points from here. So just showing like the difference between the two. There could be use cases in whatever workflow you're using where you would need this, where you need to keep the structure of the data as it flows through. So things are on different folders so you can access them differently. And we'll probably get to that as we go through the semester. This is just a very simple example I could think of now to kind of explain. Does that help a little bit?
Yeah.
Yeah. Okay. Yeah. Hopefully we'll find some more examples of where this is like really useful in a workflow. Because I guess what you could do, like if you wanted to find the average of every point, you could take every single circle, you know, like multiply this 100 times and then find the average of each one. But this is so tedious at 100 points that it's a lot more efficient just to have it grafted on a list like this. That's 2 components in place of what would be 200 if we were to do this with 100 different circles. So Yeah. Okay, so back to the workflow. So we have these segments now. We have a lot of segments. One thing that I like to check for before going into the shortest walk is to make sure there's no segments overlapping with each other. So we had these cells in 3D Voronoi. So we had these cells on a point, right? And they, by the nature of Voronoi, they would butt up against each other on this plane. So what could be happening right now is, now that we've broken it up into many segments, there's a line that was here, and there's also a line for this cell as well. So there's two lines overlapping in this example. So that is probably also happening with our exploded segments here. There's probably not 10,000 unique curves. There's probably only like 5,000 or something. So we can fix that really easily with one component. Everyone that has Grasshopper should probably also have the Kangaroo plugin. It just comes with it. And in Kangaroo, there's a really nice component called remove duplicate lines. There's also remove duplicate points. We kind of looked at that last class in a different way, but the lines one is pretty special for Kangaroo. So just grab that component. It'll work the same as remove duplicate points from last week, where it has a tolerance value of how far away the point should be before it deletes them. But it's probably not going to matter too much. If we have curves that are, or lines that are exactly overlapping, then the tolerance is probably near 0. And I think by default, the tolerance is 0.01, so that's pretty near 0. So it should be fine just to plug the segments into the L input for the list of lines to clean. And if we look at the output here, yeah, we have 5,700 lines, which is about half, which tracks with my my hypothesis of the Voronoi cells. So now our list is much, much cleaner, which is nice. Okay, so at this point, with the duplicated lines removed, we should be good to add this to the curve group input. So the curve group is the whole diagram of curves that we'll use to find paths in between. So we can add that into C. Okay, so in doing that, we fulfilled the first input of shortest walk, but P is also going to be a very important input. And we could, at this point, draw lines in Rhino if you wanted to define some paths to trace in between. Or what we can do for this class is lean on the dynamic part and actually do that in Grasshopper. So how would you define a random set of curves that go between points that we can update with a slider to make the overall output be very reliant on that slider input? So we can change one slider and get completely different patterns of outfits for this example. So how do we do that? If you remember from the last example, the very simple one, it just has a single line going in between 2 points to define that shortest walk. So we can do the same thing here. We can draw lines between random points, and then it'll find that shortest walk path between those 2 points. So how do we do that? What we can do is we can use, if you remember from this explode component, it was giving us segments, but it was also giving us the vertices of those segments as well. So these are all the positions on the curve where it broke it up into segments. So if we were to connect any 2 of these points together, we would get a wanted path, and that would go into shortest walk to run its algorithm. So that would work perfectly. So how should we do that? Well, we can start by selecting a few points, and we can do this randomly just to keep it unique, keep it kind of creative. So we can go ahead and start by flattening this list of vertices as well. We don't want them to be on separate lists. Again, we want to see them all together so we can find any connection between any 2 points on this mesh. So we'll flatten that. And we'll have to pick at random some points that we want to connect. There's a few different ways to do that, a few different random components that come with Grasshopper. But what we can use today is one called random reduce. And this will take any list, any set of points, or any set of anything actually, and it'll reduce it randomly to a set number of items. So this will take our population of thousands and thousands of points, and we can select out maybe 20 points that we want to make 10 lines in between. And that'll be pretty light for the algorithm, which will be nice. Connecting every single point together will just give us this Voronoi diagram again, which that's not going to be too fun. So we can reduce it a lot. So in this, we'll see the L input is the list to reduce. So we'll want to take all these points and reduce it down to something more manageable for shortest walk. So we can go ahead and start by plugging that into the L input. It's got this R input as well. We need to fulfill this one. This is the number of items to remove from the list. And right now, if we hover over V, it's seen that we have above 10,000 points. And if we want to be left with, say, 20 points, we'll have to remove 10,000 minus 20. So we could use a slider, but that would be pretty destructive later on. If we were to make any changes, the slider would not, again, be accurate to the 10,000 points. It could update. The number of points could change. So in order to think ahead and not be left out if this number changes, we can actually reference the number of points in that list. And we can do that with a list length, if I can spell. So list length will take any list and it'll just tell us how many items are in that list. So it should tell us there's just above 10,000 items in this list, which, yes, that's perfect. So now that we know that how many items there are, we can take 20 items off of that and then use whatever the answer of that is as the reducing factor, the number of items to take out. So if we want to subtract 20 from it, I mean, that's pretty simple. We can use a subtraction component, plug in whatever number we want to subtract by, and it'll do that math. Easiest way to get this is to just put in a dash and negative sign. That'll give us subtraction. And we'll take the overall number of everything, so 10,000, and we can subtract that by the whatever is in B. And we can use a slider for that to set however many number of points we want to reduce. So that should hopefully be a simple setup. One thing I'll note about the slider is in this case, if we want to draw lines, a line, as you know, is defined by 2 points. And if we have a slider, I could put the slider to 3, and that's not going to give us too much usable data. We can draw one line with 3 points, but we can't draw 2. We would need 4 points for that. One thing we can do with the slider, once we have it on the canvas, is actually right-click on it, and there's this button called Edit. This will open up a bigger panel, and you can do this if you're interested. It's not necessary, but in this panel, we have a lot more control of what we can do with the slider. You'll see up here, these two, we can do floating point, so a decimal place, or as it is right now, an integer, so a whole number. But we could also say it can only select even or only select odd numbers. If we want to draw lines, it's probably best if we just let this only select even numbers. And now if we hit OK, we can only ever select an even number. So anything divisible by 2, which will allow us to make lines really nicely. So you can do that if you like, just a little tip there. So now with this equation set up, just a subtraction, we can plug that into R. And now we'll be subtracting just however many number of points that are on this slider. So I've taken out about 10,000 points, and we're left with just 18, which is nice. Does that make sense for everyone? Let me know if it doesn't. Okay, so at this point, we'll just want to draw a line with all the points that we found. So we'll grab that component, just the line component. Line has A and B, so we'll need to fulfill A and B to create a line. We can't much fulfill that with the current list of just 18 points. We'll have to break this up into groups of 2. So we'll have 2 points for every line. So how would we do that? So I'll move this over a little bit. So there's a lot of ways we can edit lists to kind of break it up into two different or multiple sets of 2 points. And a lot of those are going to be in the set list panel. The one we'll want today, though, is a partition list. This will take any list and it'll partition it out into smaller chunks of data. So it's got two inputs, the list to do the partition on, and then the size of the partitions themselves. We know a line needs 2 points, so the partition size should probably be 2. So each partition will just have 2 points within it. We can add a slider to fulfill that number of 2, or we can use a panel to fulfill that number of 2. Personally, I would use a panel for this case, just because we'll never need to change this number. There'll be no reason to change this from 2. A line will always just have 2 points. So I'm not sure if I've explained it before, but if you want to create a panel in your scene, you can double click and type in 2 forward slashes. That'll give you a panel. But if you want to autofill the panel on creation, you can do the 2 forward slashes and then whatever you want to fill it with. So in this case, a 2, and it'll give us a panel with the number 2 pre-populated in there, which is perfect. And we can just wire that up to the size of the partition. Once we have that, if you haven't done this already, the list will go into L. And now, if you look at the output of this, we've intentionally created, in this case, 9 different branches, each with 2 points on the branch. So now we can just use a single line component with all those branches to create 9 different lines. But you'll notice we have 2 inputs, A and B, and we only have 1 output here. So we'll just have to break this up from a single stream into 2 different streams, A and B. And we did this last week as well, but I'll do it again. So we can do that quite easily with a list item. This component traditionally would use an index to grab a certain item out of a list. In this case, we're not going to do that. We're going to do something slightly different, but to start, again, plug it together. So the output of all the chunks will just go into the list. And we'll want to find A and B. So if you remember from last week, the output for this is just the lowercase I. So this is giving us the first index, index 0, so point A. But we also want to find point B for this as well. And if you zoom into the list item, these little plus signs will come up. So if you hit the bottom one, this will add I plus 1. So this will be the second index, so point B. So we've taken that stream from partition, we've taken that, that data stream, and we've broken it up into each point in the list. So A and B, I, and I plus 1. And this will also maybe answer the question from earlier of why you would graph something. So at this point, we can plug those 2 outputs into A and B. And you'll see in Rhino, we'll get a lot of random lines showing up in the scene. We can change the slider from the subtraction to get more random lines all over the figure. And we can also, because this is a component with randomness involved, as I mentioned last class, it has a seed value. So this is optional, but you can add any number into the seed. And we can see if we change that, we'll get a different random set, in this case of 9 lines. So a different random set every time I change this number. So up to you if you want to add the seed or not. Not required, but could be fun. Okay, so now we have those wanted paths. We have a line going from 2 different points. And what this will do is we've got the body, which is good enough. And we found 2 points. And we found a line in between. So now, I'm not good at drawing, so I drew this. So at this point, let's see, we've got these 2 points. And it'll find the shortest path based on that line to connect the 2 dots. So we have everything we need at this point to fulfill that. Only thing left though, if you pull up this line, you'll see it's dotted. It's not going to be great if we have a dotted line and a not dotted line going into things together. So just like we flattened the last one, we'll flatten this one as well and hook it up there. And once you've done that, you should see on the mesh in Rhino some green lines showing up. Well, they might not be green for you, but some lines showing up that are kind of stuck right onto the mesh itself. So it's using this original system of curves to draw a line on. If you have a low number for the Voronoi, the line might be pretty jagged. If you have a really high number of the Voronoi, the line will be a lot smoother, but it'll probably take longer to generate as well.
I'm getting an error that says solution exception index was outside of bounds.
Yeah, so that might happen for some people. One thing you can try, and this is the reason why we did like this work in the beginning to remove duplicate lines and clean it up a little bit. You can also use a component called clean tree. What might be happening, which shortest walk is a little bit finicky, what might be happening is you've got some curves going into C that are infinitely small, and it doesn't know how to deal with them. Or there could be some null curves in there, like just a data item that doesn't exist. So if you hook the curves into the data tree to clean input, so it's going to be this bottom one here, and then wire that into C, see if that does anything.
I'm still getting that error.
Where did you go to just type that in? Type in clean tree.
Yeah, so if you double click just anywhere not on a component, so anywhere on the gray canvas, you should get a little search bar that comes up.
Okay.
Yeah.
The search keyboard.
Yep, and then you can do clean or CLTR, clean tree, whatever you want to find that. For that error though, if you try changing the original populate geometry, if you change the number or the seed of this just to get a different random set of points, I wonder if a different random set of points will not give you the error.
Right.
That's usually what people have done in the past to fix this during class. What you could also try, one thing that might be happening is when we remove duplicate lines, what we did is we basically changed the list of curves. So the curves are their own thing, and then the lines that we made to connect them use a slightly different set of data, just because we've done this operation in the middle. So what we could do is we could take if you use this component called discontinuity, we can grab this. What this will do is it'll find those points on a curve again where it's broken up. So wherever the curve is discontinuous, it'll give us a point. So we could use the clean, actually don't even use that one, use the clean tree so we have no changes between the two different sets of data. You could do discontinuity to find the points that define the actual original curve group. And we could just use, if you flatten that, we could use this list instead of the vertices from explode. And one tip I'll give for everyone too, if you're moving wires around, you could drag this and like put it into here and here to replace it. Or a little tip for just speed of workflow is if you hold Control-Shift on the keyboard, so Control-Shift, and then you go grab this output here, we can pull these wires out of the component that it was in. So Control-Shift, and you can like take stuff. And then we could go over to the input for the output for discontinuity, and you could drop it there, and then you can see we can like move whole sets of wires at once. I'll do it again. Yeah. Okay. If you do Control-Shift on the keyboard, just press down Control-Shift, and then if you hover over the output, we should see this little white like curved arrow come up when you get to that output. If you left click, while still holding Control-Shift, so I'm holding 3 different buttons at the same time right now. So the left click and Control-Shift, and then you can take stuff out of an output and put it into a different output. So you can take it from explode and put it into discontinuity, and then just drop it, and it should take that whole like set of wires and move it over. So it's just like a workflow thing. You could, like, you don't have to do that. You could also just drag stuff like that. That also works, but They're not equal? Wait, what was that again? Your okay. Probably for one of these lines. So I mean, I'm assuming what that's saying is there's a line that's very, very small and it's not working, which is cool. It's great. I don't know why I'm getting none of those issues that you guys are getting. It's fun. Lan, if you change the slider for the populate geometry just a little bit, like you'll get a different random set. Seed would also work too. Yeah, just a different random set. How's it going over there?
Now it says this component of this
Runtime error. Interesting. Yeah, I don't know what to do for that. So people are getting more errors now. That's cool.
Can you just zoom out to the overall?
Yeah.
Because I wonder, I might have just missed like a flatten somewhere.
Yeah, so I mean, there's a flatten on, like everything going into shortest walk should be flat. That's like the main thing. Lan, are you still getting that like smallest curve error? Like for every seed value? Yeah. Yeah, I mean, there's a lot more we could do for these kinds of errors. Like you could test for every curve's length and then delete the ones that are way too short. It's a possibility. It's more steps. Yeah, which section?
The front one, just the like very beginning.
Yeah.
And then
Yeah, so yeah. Then you can just drag the wire like backwards from input to output. Cool. Yeah, there's some more plugins for that too if you're interested in like workflow optimization. I've got one where you can just box select wires and like delete them, which is really handy.
I'm still getting the same error. I think everything is hooked up like it should be.
Yeah.
So I'm not sure what to do.
Yeah. I'm gonna put this mic down quick.
Yeah, I think this is.
I mean, it does work differently. I think so. Like, it works, if you see the data, it works well for now. Well, I just changed his number and it's a lot. Yeah, maybe. Yeah. It seems that most computers, they always look at the photo. So,
I didn't know if I was doing that.
yeah, that's about, so on that original population, if you just, grab another slide, it's, yeah, I mean, I do like a C, like 1 to 10,000 or something. Yeah, so it's in something.
Okay, so yeah, if the component's orange, then that's fine. If it's red, it's bad, but orange is okay. So if everyone's got like a set that kind of works at least, that has some curves on it, you can go back and change stuff a lot later if you want to like actually art direct like where the curves are. But we'll keep moving forward for now. So let's see, we have some curves. Let me get something a little bit different maybe.
I changed my seed to like 1,000 and it worked with 100 points. So I guess it just, I
Okay. Yeah, there you go. Now let's just do more. Yeah, cool.
So for shortest walk,
Yeah.
what does it do? There were some lines, especially around the arm, that
Yeah.
were like self-contained, so just like a ring.
Mm-hmm.
Does it have a hard time trying to figure out that like distance there?
Yeah, if there's like an island, it's not going to be able to connect to there. You can see on mine, I'm getting a couple, well, a whole list of them, that it's asking if the endpoints are isolated. So it's saying there's no way to connect to this point, so it's throwing like an orange error, which is not going to stop it from working. It's still outputting everything it can.
Right.
But yeah, if there are islands, it's not going to connect it. You could do a lot more though with this original list, like to test for that island nature and then add a connection if that's the case, like you could. So we'll just try to keep it simple today. See you next week. Yeah. Perfect. Yeah. Yeah. Yeah, that's all good. Yeah. Okay, so at this point we have a curve group on the body, which is cool, but symmetry is also cool. And we can get symmetry with this pattern really, really simply by using pufferfish. So there's a lot of tools in pufferfish that we can talk about later. Actually, next week, we'll be doing a twisted box workflow with pufferfish, which will make some really, really awesome jewelry. But for now, there are a lot of, let's see, there's a lot of components. I'm not going to go through the list, actually. There's a group of components called mirror in pufferfish or mirror cut. It'll cut something and then mirror it on that cut line. So we can take kind of a random set of curves like this, define a plane of mirroring, and then swap it over so we have like a really symmetrical pattern. So for that, we can use a component called mirror cut curve. So this first one right here. So mirror cut curve. There's a lot of inputs. A lot of them don't matter. The only ones we care about are the first two. So curve and mirror plane. The first one hopefully makes sense. We need curves to cut. We have curves from shortest walk. So we have the W output, the shortest connection curve, so the walk. We can plug that into C. And we'll also need to define a mirror plane, so where we want to mirror. It's kind of up to you, but I'm going to mirror like straight down the midline. And would anyone know how to find what plane defines the midline of the person here? Yeah, it is ZNY. Yeah, so we've got this little compass down here, and we can see like down green is YZ. I lined up the person right on the origin point for you, which will make things simple. So we can just type in YZ and we'll get a YZ plane. If we plug that into the mirror plane, then we'll start to get this curve set that is mirrored across that line on the body. One thing you could do, say it's giving me an output, but say I don't like it and I kind of liked like this section of lines on here, and it's only giving us kind of this section of lines. There is an input here called flip. That's just a Boolean value, a true false value. And we could change this to be true. You can either do it by right clicking, or the better option would be to use a Boolean toggle. This is a true false button that we can press. So if we wire that into the Boolean input for flip, then if I double click on this, I can choose between one of two mirror cutting options. So either mirroring one side or mirroring the other side. And I think this one looks more interesting, so I'm going to go with it. But all of yours is going to be completely different than what I have, probably. So
It's only mirroring like the top half of that. Maybe everyone's playing it.
Yeah, I mean, if we did this on if we did it on XY, it'd give us a whole duplicate person in that Stranger Things reference of the other, I forget what it is, but we don't want that. I mean, it could be that your curve group like doesn't exist on that side on the mirror, and it's like taking the emptiness. But that's why flipping sometimes works. Or you could also just, again, go back to the very beginning, change some sliders, and you'll get a completely different curve set.
Or is it possible to take these lines and turn it into some type of like clothing item or like jewelry piece that you either use the space between, right? Like you have, I guess, like an enclosure that could either be a positive or a negative space. Can you use that to create some type of surface or something?
You definitely could. And I've done that a lot in the past, which it's good you asked the question. Yeah, there are ways that you could find the kind of negative space and use that as well. And I'll explore a couple different ways. The next plugin that we'll use right after this, right here, will kind of show some of those ways that you could cut and find different areas and things. We're going to use Dendro next as a plugin. Dendro is a a voxelization plugin. So what that means is it'll take any input and, well, does anyone know what voxels are currently? Not really. You know what pixels are, right? Wait.
So I have pufferfish,
Uh-huh.
like the original thing, and it's just.
Oh, you probably didn't unblock it then. I would just check your components folder and make sure it's unblocked. Like if you don't see the tab up top, then that's probably the issue.
No, I have the tab, I just don't have the sub D tools, but I still have like the actual thing.
What do you mean the thing?
Sorry, plugins.
Okay, so but you can only see sub D. I mean, I wonder if the file you added to the components folder is unblocked or not. Like the sub D might be unblocked, but just check that one. Yeah, I mean, this is the only component we're using from pufferfish today. So if you don't have it, it's not going to matter too much. It just won't be symmetrical. You could use mirror, yeah, and it wouldn't cut it. It would just mirror it, but it would also work, yeah. Okay. You could use the mirror component. It's a good point. Thank you. Okay, so voxelization. You know what pixels are, right? Everyone, you have pixels in front of you. So it's like a 2D grid of boxes, or I guess in pixels it's like a square. Voxels, though, are 3D pixels, if I had to explain it. So if you think of like Minecraft or Legos or something, that's like voxels. It's like a lot of different squares building up a 3D shape. Dendro does the same thing, and the reason why we use it is, if you remember the pipe from last class, that it worked very badly. Dendro also has a way to make pipes, which is much, much better. And the thing I like about it the most is it has these Boolean operations, so union, intersection, or difference, that if you have ever used Rhino's union, intersection, or difference, they kind of work. They're kind of also really finicky sometimes, which isn't great. But this method always works, and it always works really nicely. So I like Dendro a lot for that, especially if you're 3D printing and you want to make watertight meshes. Dendro is perfect for like that workflow too. And then to Joe's question, so if you had like these pipes tracing the curves and you wanted to find the surface in between, you could take the body and then use the curves to cut it out, and then you like be left with those in-between spaces, which we won't cover today, but is definitely something you could do with Dendro. Okay, so this is the kind of the last step to make the physical piece that is around the body. And we can make pipes based on these curves. We can smooth out the pipes to make a really nice smooth shape. So I'll show you how to do that. With Dendro, basically the way you work with Dendro is you can take kind of any geometry to start with. You can use curves, points, meshes. You'll convert it to a voxel state. You can do some operations on that voxel. So you could do any of the Boolean operations. You could put a filter on it to smooth it, offset it, blend it, what have you. And then you can convert back to a mesh to then work with that mesh going down the line of Grasshopper. So you go into Dendro, you do stuff, and then you go out of Dendro to do other things, because the voxel state can't be used with other plugins. So in order to convert into the voxel state, we have curves. So we'll want to take those curves and make them into a volume. So we can use that curve to volume component to start. You'll see there's a couple different inputs here, and I'll pull up the pipe as well, just so we can reference last class versus this class. They both start with the same two inputs. So we have curve, we have the radius value, same thing for the pipe. But the curve to volume component has an extra one at the bottom here called settings. So the settings is going to define how detailed the voxel is. So let's say we have a slider from 0.1. Okay, we have a voxel from 0.1 to +1, a whole integer. And if we put a voxel at the state of 1, so a very large number per se, just a large number, then the voxel itself will be made up of large blocks. So if we had, like, I don't know, someone's head, and we made it out of large voxels, it would kind of look like this, which is not a head shape at all. But say we had another head shape, and we did a value of 0.1, so a very small number, Then, bear with me for 10 minutes. So if I say we get a lot of small voxels, and then this would like reference the shape a lot better. So that's kind of the detail setting that's going into Dendro. I kind of like these, so I'll keep them. And we can define that setting with this first component called create settings. And this will actually define like what detail we're going to get in the voxel state. Again, we get higher quality with lower numbers, but this will also take a lot more time to generate. As you can see, it took me a lot longer to draw, so it's going to take the computer a lot longer to draw as well. Same applies. But going into the settings, the only input that really matters is S here, so the voxel size. So as I just said, what I usually like to do is start with a slider of 0.1 to 1. The reason I do this is because we'll probably end up using a number close to 0.1 because that's going to give us the most detail. But 0.1 is going to take a long time to render. And we don't love that for prototyping because it's going to take a while. So I put down the slider and then immediately drag it to that high value. So we can start with a really high number. The detail, it's probably going to look awful. It's probably not going to look like what we want it to look like, but at least it'll take 0 seconds to calculate. And then we can kind of refine this number lower and lower to get more detail when we start refining the shape. But so slide it up to 1. We'll add that into the voxel size of S. And then once we've done that, we can use this now created settings to populate the settings input of the curve to volume. So now we have some settings for the volume to follow. The only thing we're missing is a radius value to complete this. So we can use any radius. I will note though that if we're making a pipe, I'll do another drawing. This is not a head, so it should be better. If we have the radius as this, the radius is 1, right? The voxel size is also 1. So it's gonna be like really big. It doesn't like when you do this because there's not much to go on with a single voxel. It's gonna yell at us if we put in a value of 1 for the radius because the radius should be at least 3.4 times larger than the settings. So we can have like at least some definition inside the pipe, but we'll see this in a second. So create a slider for the radius. I'm gonna go like 0.1 to 5 just so we can start high again. And then once we have all that, we can plug the curves into the curve to volume. Is it working? I don't. Okay, it's not working for me, which is cool, but it's not working, so we'll clean it, and that works. So that's cool. Yeah, so it's very massive now. But if I were to make the radius 1, okay, it's going to start giving me an error saying that the radius must be at least 33% larger than the voxel size, otherwise nothing will happen. So it's good to note. I mean, this is cool. We're not really going for like mummy though. So I'll make it smaller, but you can see as it gets smaller that detail, it's kind of pretty bad down there. It's very jagged. So when it looks like that, you know, we can't make the radius any smaller. It's looking jagged. We can go and actually start refining this settings value. And the lower we make this, the better the definition of the surface will be defined. So 1, pretty bad, down to 0.3, looking pretty good. And I think now at 0.3, we should be able to make the radius smaller too. One thing about Dendro, which is pretty cool, you'll notice right here at this intersection, as the radius gets big enough for the two sides to combine, we're actually getting, like without doing any extra work, like a really nice boundary connection right here, where the two sides have come together. They're not like overlapping meshes as you would see if you're working any other way in a 3D software. It's actually just becoming one continuous surface at that intersection, which is really nice. This is why I said it works well for 3D printing, because you're not going to have any overlapping faces or surfaces anytime that you work in Dendro because of this fact. So it's really nice. But we don't really need that. We'll make this a lot smaller to get a better curve. Cool. Okay, so yeah, question?
Mine's still, I cleaned it and it's still red.
Which one?
Volume to curve. is still red. Well,
Okay,
after I
well-
did the clean tree,
Yeah, did it work with Clean Tree?
no, it didn't. I have
What is the error saying?
able to load DDL or DLL.
Okay, so I believe what happened is the plugin there's something wrong with the way you installed the plugin. I'm assuming it's just not unblocked correctly. Because the DLL is one of the components. So this one, I'm assuming it's just not unblocked in your settings, and that's probably why it's saying that. Okay, so one other thing I really like about Dendro is the way we can clean up the surface as well. I mean, you can see all the curves have combined really nicely to form the surface, but if you want to maybe smooth out the surface even more, there is under filters this one called smooth volume. If we plug this all together, smooth volume will start to take any sections that were tight, like this connection point is pretty sharp. Smooth volume will start to smooth out those areas. And we can also increase the iterations. This is optional, but it's kind of nice. We can increase the iterations of smoothing. So right now it's at 1. If I go higher with the slider, we can see that these intersection areas will start to become like super smooth as it smooths stuff out and gets smaller. Maybe we'll make the radius a little bit bigger, smooth it more. Yeah, and now it's a lot more amorphous than what we had to begin with. If we look at the original one, it follows the line quite well, which is something you might be going for. But if that's too rigid, we can smooth it out and then start to have something a lot more natural and like flowing with the surfaces. So that's what smooth volume would do. And you can really play around with the settings, the size of the voxels, the size of the radius, and the iterations for smooth. And like a combination of the 3 will give you very different looks. My radius is quite high right now because I know if I have a high smoothing iteration, it's going to take away a lot of volume. So the radius is really big. But yeah, a lot of stuff you can play with just with these couple components. So. What does it say? Did you use a clean tree in the middle? Yeah, let me take a look at it. Well, yeah. Oh, on that.
I think it might be around if you run the yeah. Yeah, gotcha. Yeah, mine's only following part of the curves. But the Dendro part? Yeah, it's only 3-dimensional curves. And are you going to do one? I did at the end. You can do about as good as you can. Only do 7 what's the other? Because this is still not. Yeah. I mean, you can do what one. So, yeah, sometimes Dendro has an issue that doesn't enjoy curves all that much. Usually, I'll go into a file and just it, and then try to use. I could.
Okay, so. Okay, I just put a file in Discord. Open up this one, curve from points.
Okay, just double click it.
Yeah, just open that up and I'll open it up as well.
Okay.
Okay, so I've made this little section before for this issue. What this one does is it takes your curves, it divides it into points, and then it uses those points to create a volume. This is a much more reliable method for creating pipes. I've heard, like, from the person that wrote Dendro, they said the curve to volume component is basically doing this itself. Like, it takes a curve, it makes points, and then it makes a volume on those points. So everything is just working on points. So let's see, with this, you could just take your curves, plug that into the input curve, and then you should also get a similar result of it gives you pipes just like the other one does. So, and this one should be always reliable. So I just do that and see if it works.
So just copy it out and put it to the other.
Yep. And one tip I'll give everyone too, like, you can take this, just drag over everything, Control C to copy. You can go back to your other file and Control V to paste it, but it's going to paste it in the top left corner. If you Control Shift V, it'll paste it just where you're looking, which will be nice. Okay, we don't have too much time left, but it'd be cool if everyone could post just a screenshot of what they were able to make in Discord. Before you do that though, color is always fun. So if you want to put a fun color on it, you can use the custom preview component with a color swatch. And that'll give you whatever color you desire. That'll make for a good screenshot. Yeah, that's nice. Yep. Okay, now mine is split die, but that doesn't do much. Yeah, custom preview is just the easiest way to do it. There's other ways if you want to do gradients and things. We just don't have too much time left to set that all up. But if you want to, I mean, you could follow this. All this one is doing is it's applying different colors to different vertices of the mesh, which is a simple way to do it. If you want more control, and I can put these in Discord after class. Let's see. If you wanted more control like this one, let's see. This is a section for it. So it's using an attractor point, just like we kind of used in last class. So there's a point down here at the center. And then it's looking at all of the vertices of the mesh, measuring a distance between the point and the vertices, and then applying a color based on the distance away it is. So you could do that as well. Yeah. Does anyone want this to take a nice photo with? Okay, I'll just post this file in here. You can copy stuff out of it. Let's see. Shortest walk outfit. Okay, so if you grab that file, you can just take this final block, plug in your mesh, and then it'll give you fun colors. So yeah. I'll take a picture of this one. So you could take a screenshot, or if you want to be a little bit fancier with it, let's see. In Rhino, just a tip for Rhino, if you want to take a screenshot from Rhino, there's a command called view capture to clipboard. This will just capture it like to the clipboard on your computer. I'll just hit OK, and then let's just, if you take a photo, we'll just put it in homework for now. It's a nice spot. You can just paste it like that, and that's easy enough. So again, that was view capture to clipboard, and that would do that. Like to do it, feel free. If you just want to use color swatch, that's the simplest method, but have fun with it. That's all I had for today. If you have questions, I'll be here for a little bit. If not, go get some chocolate or something. So yeah, yeah, totally. Mm-hmm.
Never. Yeah, so just saying that. That's not true. Yeah. If you can find one that works, not really. I mean, we are doing something a little bit new because there's a mesh and doing the mesh and all that. So, I mean, it's not the easiest way to work with it. It's a fun way to work with it. But yeah, I would just slide it around until it kind of works. Oh, okay. Yeah. Yes. So that is yeah, that is if you use the right before that has purpose. So it's the one yeah, you drag that. That should actually. So this is I got this. So yeah. It's still listen. I always do. That was the best one. You can see like the highlight. Zero is not a Y. It's funny. Yeah. Because it is zero. Well, we could say that. Yeah, it's this. I was looking at this. It's a little larger than that. I mean, if the two of them things are like this. So we could say, if all Yeah. Okay, there we go. Yeah, so this is your problem.
I was thinking that person, but I said
Yeah, you kind of on it. You don't have any other. The next.
Not doing that.
Yeah, I didn't do that one in class. Yes. Yeah, then do I like that a lot. We will make it easy.
Does anyone on Zoom have questions?
Yeah,
Or-
yeah. I was wondering if I could share my screen with you.
Yeah, totally. Let me stop the recording.